A planet drifts alone through endless night, forever cut off from the light of any star. These are rogue planets, cosmic orphans, wandering the eternal darkness between suns. By the end of this journey, you will understand how these solitary worlds force us to rewrite the rules of what a planet can be. We will explore 15 of these mysterious wanderers, from a magnetic powerhouse to a lonely giant, uncovering how they were born from violent chaos and what their frozen surfaces might hide. Could life survive in such absolute cold? And do these dark nomads outnumber every star in the sky? What does it feel like to imagine a world that has never seen a sunrise? Think of a great ship, its mooring line suddenly severed, silently pushed away from the harbor lights into the vast, dark ocean. That is the journey of a rogue planet. It is a world of planetary mass, but it travels alone, bound to no star, navigating the interstellar void under its own momentum. Astronomers call them free-floating planets or interstellar planets, names that speak to their solitary, untethered nature. This is a crucial distinction. These are not simply oversized asteroids or failed stars. Many are thought to be true planets, born in the dusty disks around young stars, just like Earth or Jupiter. Their story, however, took a violent turn. Through gravitational chaos, perhaps a close encounter with a sibling giant, they were hurled out of their home system, cast adrift into the galactic deep. The discovery of these cosmic orphans fundamentally changed our understanding. For centuries, the very definition of a planet was tied to a star. Now, we must accept that planets can exist independently, as sovereign worlds wandering the darkness. This single idea shatters old categories and opens a floodgate of questions. If planets can be ejected so easily, how many more are out there, invisible to our telescopes? Could these dark wanderers, hidden between the stars, actually outnumber all the planets that orbit suns? Their silent journey forces us to look at the galaxy not as a collection of well-ordered solar systems, but as a sea filled with unseen, nomadic worlds. The birthplace of a rogue planet is a nursery of chaos. In the swirling disk of gas and dust around a newborn star, young worlds are jostling for position, their orbits still unstable. The dominant force in this celestial arena is gravity, and the heaviest players, the gas giants like Jupiter, wield immense power. In this formative era, a close gravitational encounter can be a world-ending event, or rather, a world-ejecting one. The primary engine for creating rogue planets is a process astronomers call planet-planet scattering. Imagine two massive worlds, their orbits bringing them perilously close. Their gravitational fields interact like a slingshot, a violent transfer of energy. In most cases, one planet is flung inward, while the other is hurled outward. But sometimes, the smaller or less massive of the two receives such a tremendous kick that it achieves escape velocity. It breaks free from its star's gravitational grasp entirely, catapulted into the blackness of interstellar space at speeds that can exceed 100,000 miles per hour. This is not a gentle drift but a violent expulsion, a world sentenced to an eternal, frozen exile by the very forces that gave it form. There is another, more solitary origin story. Some of the smallest rogue planets, particularly those on the boundary between planet and failed star, may have formed alone from the very beginning. They could be the product of a tiny, isolated gas cloud that collapsed under its own gravity, but never gathered enough mass to ignite the nuclear fusion that creates a star. These lonely objects born in darkness never knew the warmth of a sun. This violent and varied birth explains why hunting for these objects is one of astronomy's greatest challenges. They emit no light of their own, and with no nearby star to illuminate them, they are cloaked in near-perfect darkness. To find them, scientists must become cosmic detectives, looking for the faintest of clues in the empty spaces between the stars. Finding such a world is like searching for a single, unlit ember in a field of absolute darkness. To spot an object that emits no light, hidden in the vast emptiness between stars, astronomers cannot rely on traditional observation. They must instead watch for the subtle ways these dark wanderers bend the very fabric of space around them. The most successful technique for this hunt is called gravitational microlensing. It relies on a prediction from Einstein's theory of relativity that massive objects warp the space around them. When a rogue planet drifts precisely between our telescopes and a distant background star, its gravity acts like a lens. It briefly bends and magnifies the light from that faraway sun, causing a distinct temporary spike in brightness. For a short time, the invisible planet reveals its presence by making another star grow brighter. It is a ghostly signature, a fleeting event that requires immense patience and precise timing to catch. This method has proven incredibly effective, revealing dozens of candidates, but it is a passive hunt. You can only observe where and when the cosmic alignment happens to occur. A newer, more active form of the search is now changing the game: direct imaging. With instruments like the James Webb Space Telescope, astronomers are not waiting for a chance alignment. They are pointing their most powerful infrared eyes directly into the dark, looking for the faintest glow of warmth. A young rogue planet, perhaps only a few million years old, still retains heat from its violent formation. To Webb's sensitive infrared detectors, that residual warmth is a beacon in the cold. It appears as a single, lonely pixel of light, a pinprick of heat against the cosmic backdrop. These two technological marvels, one watching for distortions in starlight and the other sensing ancient warmth, are our only windows into this hidden population. And what they are showing us is startling. The number of candidates they have found suggests these dark nomads are not rare exceptions. They may be extraordinarily common, a silent multitude moving through the spaces between the stars. In 2012, a faint point of infrared light forever changed our view of the galaxy's darkness. Designated CFBDSIR 2149-0403, this object, roughly 100 light-years away, was announced as the first strong candidate for a rogue planet found drifting near our solar neighborhood. Its discovery was a watershed moment. For decades, these solitary worlds were a theoretical possibility, a ghost in the equations of planetary formation. CFBDSIR 2149-0403 was the first ghost to step into the light, or rather, to emit a detectable warmth. Estimated to be between 4 and 7 times the mass of Jupiter, it was not a star, but it was still relatively young and retained enough internal heat from its formation to glow in the infrared spectrum. This residual warmth was its telltale signature, allowing powerful ground-based telescopes to pick it out against the cold backdrop of space. The confirmation that we could directly image such an object was a monumental leap. It validated the violent ejection theories, providing a tangible example of a world that had been cast out. More importantly, it proved that the dark spaces between stars were not the barren voids we once imagined. They were a frontier potentially teeming with unseen, nomadic worlds. CFBDSIR 2149-0403 was the pioneer, the first concrete evidence that our cosmic map was missing an entire population of planets. Its lonely journey showed us that to truly understand the galaxy, we must learn to see in the dark. But not all rogue worlds are quiet, frozen relics. Some burn with an inner fire we can barely comprehend. About 20 light-years away drifts an object known only by a string of numbers and letters, SIMP J013656663 plus 0933473. This lonely giant exists in a strange borderland, its mass hovering right at the fuzzy boundary between a planet and a failed star called a brown dwarf. It is a cosmic mystery defying our simple categories. What makes it truly extraordinary is not its size but its power. This solitary world possesses a magnetic field of staggering intensity, over 200 times stronger than Jupiter's own mighty field. To put that in perspective, if you could stand on its hypothetical surface, a compass would be utterly useless, violently pulled by forces beyond imagination. This incredible magnetism has a visible, breathtaking consequence: auroras. On Earth, our beautiful northern lights are ignited by particles from the solar wind slamming into our atmosphere. But SIMP J01365663 has no sun. There is no stellar wind to provide the fuel, yet it shines with its own spectacular light show. Its auroras are generated entirely from within, a product of its own ferocious internal dynamics. This means the planet is not a cold, dead stone. It likely has a churning, metallic interior, a dynamo of unimaginable scale that powers this eternal, self-made storm of light in the eternal dark. This discovery forces a profound rethink. An object like this blurs the line we try to draw between planets and stars. Its sheer power suggests it may not have been born in a disk around a star and then ejected. Instead, it might have formed much like a star itself, from a small, isolated cloud of gas that collapsed under its own gravity. It is a world that never had a sunrise because it was always its own source of energy. This lonely, blazing giant shows us that the family of rogue planets is far more diverse and dynamic than we ever dreamed. The sheer number of these dark wanderers is the most humbling revelation of all. While individual discoveries like the magnetic giant capture our imagination, the statistical view from surveys paints a picture of a galaxy fundamentally different from what we once believed. Projects like the optical gravitational lensing experiment, known as OGLE, and the microlensing observations in astrophysics, or MOA, have spent years patiently watching millions of stars, cataloging the brief, telltale brightening caused by unseen masses drifting through the foreground. Their data does not just reveal single planets, it reveals a pattern. The frequency of these microlensing events is far too high to be explained by stars or known stellar remnants alone. The math points to a single, staggering conclusion. Our Milky Way galaxy may be home to billions, perhaps even trillions, of rogue planets. This means these nomadic worlds could vastly outnumber every star in the sky, and likely outnumber all the planets that orbit those stars. The implications of this are profound. For generations, we pictured planets as the exclusive companions of stars. Now, the data suggests the most common planetary environment in the galaxy is not a warm, sunlit orbit, but the cold, eternal darkness of interstellar space. This hidden multitude represents a complete shift in our cosmic perspective. The galaxy is not primarily a collection of solar systems with empty voids between them. It is more like a vast ocean where star systems are merely islands, and the dark sea between them is filled with a silent, drifting population of unseen worlds. This forces a fundamental rewrite of the galactic census. Every time we look up at the night sky, we are not just looking at points of light. We are looking past a sea of darkness that is, in fact, teeming with planets. Their sheer abundance suggests that the process of planet formation is not only efficient, but often ends in exile. The violent gravitational chaos that ejects young worlds must be a common, almost routine part of a solar system's youth. So the next time you feel a sense of loneliness under the stars, remember, the emptiness is an illusion. The darkness is alive with countless unseen journeys. This leads to a startling question about the nature of these exiles. Are they all gas giants, or could a rocky world like our own be thrown into the void? The violent gravitational slingshot that ejects a planet does not discriminate by composition. In the chaotic early days of a solar system, when orbits are still settling, rocky planets are just as susceptible to being flung outward as their gaseous cousins. Theoretically, an Earth-sized world could be catapulted from its star, becoming a terrestrial rogue, a dark twin to our own blue marble. The image is haunting, a world of mountains, valleys, and perhaps even ancient riverbeds, now frozen in perpetual night, traveling on an endless journey through the interstellar deep. The conditions on such a world, however, would be unimaginably harsh from our perspective. Without the steady warmth of a sun, its surface temperature would quickly plummet to near absolute zero, hundreds of degrees below freezing. Any atmosphere it once possessed, the very blanket that moderates temperature and supports life, would likely condense and fall as snow, creating a frozen shell over the entire planet. It seems the very definition of a dead world, yet nature is endlessly inventive, and life, if it exists, may find a way in the most unexpected places. The key lies not on the surface but beneath it. A rocky rogue planet could retain internal heat from the radioactive decay of elements in its core, a slow, natural furnace left over from its formation. Furthermore, if it were ejected with a large moon in tow, the gravitational tug of war between them could generate tidal heating, flexing the planet's interior and creating warmth through friction. This combination of forces could be enough to maintain a vast, global ocean of liquid water deep under the icy crust, sealed away from the frozen surface above. We see this principle at work in our own solar system on moons like Jupiter's Europa. That distant world has a surface of solid ice, but a salty, subsurface ocean kept liquid by tidal forces. A terrestrial rogue planet could be a dark, planetary-scale version of Europa, a sealed biosphere traveling alone between the stars. This expands the very concept of a habitable zone. Life may not require a star at all. It could thrive in the eternal darkness, warmed from within, in oceans hidden beneath miles of ice on a world that has no sun. The surface of such a world would be a monument to absolute cold. Picture the deepest, darkest freezer imaginable, one that has never been opened to let in light or warmth, and you begin to grasp the relentless environment of a rogue planet. With no star to provide external heat, the surface temperature quickly plummets and stabilizes at a point just a few degrees above absolute zero, the theoretical point where all molecular motion stops. This is not merely cold, it is a profound and unyielding freeze that redefines the very nature of a landscape. On a terrestrial rogue, the familiar rocks and dust of a world like Earth would be there, but they would be shrouded under something far stranger, an exotic crust of frozen atmospheric gases. Any atmosphere the planet managed to retain after its violent ejection would not remain as a sky. Instead, it would collapse, condensing directly out of the air and precipitating as snow, layer upon layer, over millennia. The ground you would stand on, if you could, might not be stone or soil, but a thick, solid blanket of frozen nitrogen, methane, or carbon monoxide. The very air would have turned to ice, creating surreal plains and mountains of substances that are gases on our warm, living world. This leads to the possibility of a bizarre form of geology. If the planet retains enough internal heat from its formation or radioactive decay, that energy must find a way out. Instead of fiery volcanoes spewing molten rock, a rogue planet might host cryovolcanoes. These would be vents in the frozen crust, erupting a cold, thick slush of water, ammonia, or methane mixed with salts. A slow-motion ooze that freezes solid upon contact with the unimaginable cold of the surface. Studying these theoretical conditions is not just an exercise in imagining the extreme. It pushes our models of planetary science and chemistry to their absolute limits, forcing us to understand how matter behaves when heat is almost entirely absent. It shows us that a planet is not defined by the star it orbits, but by the complex, often beautiful, interactions between its internal furnace and the eternal winter of space. Its trajectory is a story written in gravity, a lonely path through the currents of the galaxy. While stars travel in a grand, orderly rotation around the galactic core, moving together in the vast stellar disk, a rogue planet follows no such rule. Its journey is a solo expedition, its course set by the violent kick that exiled it. This means its orbit can be wildly inclined, taking it far above and below the plane of the galaxy, or incredibly elongated, sending it diving from the crowded galactic center out to the sparse halo and back again over billions of years. Think of it not as a car on a circular racetrack, but as a lone canoe caught in a complex network of rivers, sometimes drifting slowly through quiet backwaters, other times rushing through powerful gravitational rapids created by dense star clusters or dark matter. Its speed is a testament to its violent birth, often far greater than that of planets comfortably bound to their stars. Where Earth moves around the Sun at about 67,000 miles per hour, a rogue planet can easily be traveling at over 100,000 miles per hour relative to the galactic center, a velocity born from celestial catastrophe. This nomadic existence has a profound implication that transforms these worlds from mere curiosities into potential galactic messengers. Over an epoch spanning billions of years, a rogue planet could voyage from one stellar neighborhood to another, a dark, slow-moving vessel crossing the immense voids between stars. It carries with it the elemental signature of its birthplace, the frozen chemistry of its original solar system locked in its ices and rocks. And if, by some miracle, it harbors a subsurface ocean shielded from the cold, that hidden sea becomes a sealed ark. This raises a captivating possibility known as Panspermia, the idea that life's ingredients, or even life itself, could be transported between stars. A rogue planet would be the ultimate generation ship, not built by any civilization but created by cosmic chance. It would provide a stable, protected environment for countless millennia, far more durable than a fragile comet or asteroid. While this remains a speculative and wondrous thought, it changes how we see these wanderers. They are not just frozen orphans. They are potential couriers, silent travelers on journeys so long they make human history seem like a single blink, carrying the possibility of connection across the unthinkable distances of the galaxy. This silent journey through the dark redefines where we might find life. For generations, the search for life beyond Earth has been anchored to a single, golden rule: the habitable zone. This is the narrow band around a star where temperatures are just right for liquid water to exist on a planet's surface. It is a sun-centric view of biology, one that inherently ties the possibility of life to the warmth of a stellar hearth. Rogue planets, by their very definition, exist far outside any such zone. Their surfaces are frozen wastelands, bathed in a cold so profound it seems to forbid any hope of biology. Yet, to dismiss them as sterile is to make a crucial mistake, one born from only looking at the top of the ice. The true potential for life on these worlds does not lie on the surface, but hidden far beneath it, in global oceans sealed away by a crust of ice miles thick. We see this principle at work in our own cosmic backyard. Moons like Jupiter's Europa and Saturn's Enceladus are frozen orbs, but beneath their icy shells, vast saltwater oceans churn, kept liquid not by sunlight, but by the gravitational tug of war with their giant parent planets. This internal heat, generated by tidal forces and radioactive decay, creates a stable, watery environment completely isolated from the frozen surface above. A rogue planet could be a planetary-scale version of these moons. If it were ejected with a large moon of its own, their gravitational dance could provide the necessary tidal heating. Or the planet's own internal furnace, the residual heat from its violent formation and the slow decay of radioactive elements in its core, could be sufficient to maintain a subsurface sea for billions of years. In that eternal darkness, under immense pressure and insulated by a ceiling of ice, the chemistry for life could quietly unfold, utterly independent of any star. This possibility forces a monumental shift in perspective. The habitable zone is not a circle drawn around a star. It is a condition that can exist within a world. A rogue planet carries its own habitable zone deep inside it, a pocket of potential warmth traveling through the interstellar freeze. This means life could be a citizen of the galaxy at large, not just a resident of sunny planetary neighborhoods. It suggests that biological resilience might be far greater than we ever conceived, capable of persisting in the most isolated, sunless environments imaginable. In fact, that thick icy crust could be life's greatest protector. On a planet orbiting a star, the surface is exposed to solar flares, ultraviolet radiation, and the occasional asteroid impact. A rogue planet's global ice shell acts as a perfect radiation shield and a colossal impact buffer. Any ecosystem in the ocean below would be safeguarded from cosmic catastrophes that could sterilize a surface world. This stability is measured not in millions but in billions of years. Such a sealed biosphere could become a time capsule, preserving ancient forms of life or allowing evolution to proceed along a unique, uninterrupted path for epochs longer than Earth's entire history. The search for extraterrestrial life, therefore, cannot only look toward the light. We must learn to listen in the dark, to consider that the most common abode for life in the galaxy might not be a warm, rocky planet like our own, but a frozen wanderer, its heart beating with a hidden ocean on an endless journey between the stars. To see these dark wanderers, we must learn to see heat. The James Webb Space Telescope does exactly that, acting as our most sensitive thermal camera pointed at the cosmos. Its revolutionary power lies in its ability to detect infrared light, the faint glow of warmth that all objects emit. For rogue planets, especially the younger ones still radiating the heat of their violent birth, this makes the invisible suddenly visible. Where previous telescopes saw only empty space, Webb sees pinpricks of ancient warmth, single pixels of data that represent entire worlds. This is not just about finding them, it is about knowing them. Webb's instruments can dissect that faint infrared glow into a spectrum, a chemical fingerprint of the planet's atmosphere. For the first time in history, we are not just guessing about these solitary worlds. We are beginning to analyze their air, or what remains of it, from billions of miles away. Specific observing programs are now targeting stellar nurseries like the Orion Nebula, where planet formation is rampant and the gravitational chaos that ejects worlds is most active. In these crowded, dusty regions, Webb is conducting a census of the darkness, searching for the faint, warm signatures of planets that have already been flung away. Each detection provides a precise measurement of temperature and an estimate of mass, turning what was once a statistical probability into a catalogue of individual, characterized worlds. This data is the ultimate test for our theories. Does the atmospheric composition of a young rogue planet match what we'd expect from a gas giant born in a solar system? Or does it show the signs of a more solitary formation? Every spectrum Webb captures is a direct message from a world without a sun, offering clues about its origins and its internal workings. We are no longer just imagining these lonely giants. We are starting to meet them, one faint point of warmth at a time. The future of this search is already taking shape, with new eyes being built to peer deeper into the dark. The next leap forward will come from the Nancy Grace Roman Space Telescope, set to launch later this decade. Unlike telescopes that stare intently at a single patch of sky, Roman is designed for a grand, sweeping survey. It will scan vast stretches of the galaxy with a field of view over 100 times larger than the Hubble Space Telescopes. This makes it the perfect instrument for a cosmic census, specifically targeting microlensing events. Scientists predict Roman could discover thousands of new rogue planets, from Jupiter-sized giants down to worlds as small as Mars. This will not just be a list of names, it will provide the first robust statistical sample, revealing the true population of these nomads. We will finally understand their distribution, their masses, and how common they are in different regions of the galaxy. This data will answer fundamental questions about planetary formation and ejection, telling us if our solar system's relative calm is the exception or the rule. But microlensing, while powerful, only gives us a fleeting glimpse. To truly study these worlds, we need to look at them directly for longer than a brief alignment allows. That requires a different kind of technology, one that can perform the ultimate magic trick, making a star disappear. Future direct imaging missions are being planned with revolutionary tools called coronagraphs and starshades. A coronagraph is a complex mask inside the telescope that blocks the blinding light of a star, much like using your hand to shield your eyes from the sun to see something faint nearby. A starshade is an even more ambitious concept, a separate, flower-shaped spacecraft flying tens of thousands of miles in front of a telescope, perfectly positioned to cast a shadow and blot out a star's glare. With the starlight removed, the faint, cold glow of an orbiting planet, or more importantly, a rogue planet drifting nearby, suddenly becomes visible. These technologies will allow us to see older, colder rogue planets that have radiated away their youthful heat, objects that are currently completely invisible to us. They could reveal the closest such wanderers to our own solar system, perhaps even one silently passing through our own galactic neighborhood. When these missions come online, rogue planets will cease to be rare mysteries. They will become a well-understood class of celestial objects, as catalogued and studied as the planets in our own solar system. The dark frontiers of our galaxy are about to be illuminated, revealing a hidden population we are only beginning to comprehend. Long before telescopes confirmed their existence, these sunless worlds haunted the edges of our stories. The human imagination has always been drawn to the idea of a planet adrift, a dark double to our own stable home. In science fiction, they became powerful symbols long before they were scientific fact. A classic example appears in the film The Empire Strikes Back, where the heroes take refuge on the remote, asteroid-shrouded world of Hoth. While Hoth orbits a star, its depiction as a frozen, isolated outpost at the edge of known space perfectly captures the feeling of a rogue world, a place of extreme hardship and resilience far from the galactic centers of power. More directly, the concept drives the plot of the modern epic The Wandering Earth, where humanity literally moves our entire planet to escape a dying sun, turning Earth itself into a colossal generation ship on a nomadic journey. These stories are not about astronomy, they are about us. A rogue planet, in narrative terms, is the ultimate frontier. It represents absolute isolation, a test of survival against the coldest, darkest environment imaginable. It can be a place of exile or a hidden refuge, a prison or a sanctuary. This thematic resonance is why the idea feels so compelling. It taps into deep human narratives of perseverance, of finding light in the darkness, and of venturing into the complete unknown. The discovery that such worlds are real, and not just literary devices, adds a profound layer of wonder to both the science and the stories. It means our myths were, in a sense, preparing us for a stranger reality. When we watch these tales of survival on frozen worlds, we are no longer just enjoying fiction. We are glimpsing a possible future, or pondering the silent histories of real worlds that travel the same eternal night. This cultural reflection makes the scientific pursuit of rogue planets feel deeply human, a quest to understand not just the cosmos, but our own place within its vast and lonely expanse. The sheer scale of the rogue planet population presents one of the greatest puzzles in modern astronomy. If these dark wanderers truly outnumber the stars, we must ask why the galaxy is so prolific at creating orphaned worlds. The leading theory of violent ejection from young solar systems is compelling. but the numbers are challenging to explain. Is the chaos of planet formation so extreme that flinging worlds into the void is a standard part of the process, or are we missing a fundamental piece of the puzzle? This leads directly to the question of their origins. While many are likely ejected exiles, others, especially the very low-mass objects, might have a completely different story. Could some of these objects form in isolation, collapsing from tiny, cold clouds of gas and dust in the dark spaces between stars, never knowing the warmth of a stellar nursery? The answer would reshape our definition of a planet itself, suggesting two distinct pathways to planetary existence, one bound to a star and one born free. Unlocking these mysteries requires knowing not just how many exist, but what they are made of. What is the full range of their masses and compositions? Current detection methods favor finding Jupiter-sized giants, but the true population likely includes everything from super-Earths to failed stars. Are there Earth-mass rogue planets of rock and iron silently drifting through our neighborhood? Without starlight to analyze their atmospheres, determining their composition is a monumental technical challenge. Each faint pixel of warmth detected by the James Webb Space Telescope is a treasure trove of spectral data, slowly helping us build a library of what these worlds are like. But the most tantalizing question of all involves second chances. Could a rogue planet on its billions-year journey be captured by the gravity of a passing star? If so, a cosmic orphan could find a new home, becoming an adopted exoplanet in a foreign solar system. This possibility turns planetary genealogy on its head. Some of the exoplanets we've discovered orbiting other stars might not be native to that system. They could be captured nomads, survivors of a deep space journey now settled into a new orbit. This idea suggests a dynamic, interconnected galaxy where planets can change families, adding a layer of cosmic migration to the story of life. Every one of these unanswered questions is a beacon for researchers, highlighting how the study of rogue planets is a field just awakening. Each new detection, each subtle spectral line, has the potential to upend a comfortable assumption. A single discovery of a captured rogue planet, or clear evidence of one that formed in isolation, would rewrite textbooks overnight. This constant state of potential revolution is what makes this frontier so electrifying. It reminds us, in an age where we map galaxies and peer back to the dawn of time, that our own cosmic backyard still holds profound secrets. The dark reaches between the stars are not empty. They are a frontier alive with mystery, where every faint point of warmth tells a story we are only beginning to learn how to read. Their silent multitude forces a profound reassessment of our own home. For centuries, we have studied our solar system as the model, a stable arrangement of planets orbiting a single star in what appeared to be a peaceful, enduring order. The prevalence of rogue planets shatters that comfortable assumption. Their sheer numbers tell us that the chaotic gravitational scattering which ejects worlds is not a rare catastrophe. It is a standard feature of planetary youth. This means our own orderly system, where planets have maintained stable orbits for billions of years, might be the cosmic equivalent of a quiet suburb in a galaxy filled with turbulent neighborhoods. We are the exception, not the rule. This realization injects a new urgency into studying our own solar system's history. What early event, what forgotten gravitational dance, allowed our giants to settle into their harmonious rhythms instead of flinging each other into the dark? Were we simply lucky, or is there a stabilizing mechanism we have yet to fully understand? The existence of these dark wanderers turns our local cosmic history into a detective story with higher stakes. Their journey also demands we expand the very definition of a planet. For so long, our textbooks tied a planet irrevocably to a star. Now, we must accept a planet as a world defined by its own mass and formation, not its address. A planet can be a sovereign entity, a traveler of the interstellar deep. This conceptual shift is monumental, opening the door to a far richer and more varied galactic family than we ever conceived. It fosters a necessary humility about our place in the cosmos. We live on a world bathed in constant sunlight, orbiting a stable star, conditions we have come to see as essential for life. Yet the galaxy whispers a different story through these nomads. It suggests that the most common planetary experience is one of profound, cold, and eternal night, a journey through darkness measured in eons. Our sunny, star-bound existence is a precious anomaly. This perspective does not diminish our world, but it reframes it. We are not just inhabitants of a solar system, we are residents of a galaxy alive with countless unseen journeys. Every time we look up at the starry sky, we are gazing past a hidden ocean of nomadic worlds, a reminder that the universe operates on scales and through processes that both include us and far exceed our parochial experience. The study of these dark wanderers, therefore, is more than planetary science. It is a lesson in cosmic perspective, teaching us to see the galaxy not as a static map of stars, but as a dynamic, flowing sea of worlds, most of which travel in a silence we are only just beginning to hear. Our journey among these 15 wanderers reveals a galaxy far more populous and dynamic than the star charts suggest. These solitary worlds, from the magnetic powerhouse to the frozen giants, are not mere anomalies. They represent the unseen majority of planetary bodies in our cosmos, a silent multitude traveling the eternal dark. Their stories, born from violent ejections in chaotic nurseries, challenge the very definitions we once held sacred. A planet is no longer defined by the star it orbits, but by its own sovereign journey through the gravitational currents of the Milky Way. This realization ignites a profound curiosity about resilience in the most extreme environments. Could life persist in a global ocean sealed beneath miles of ice, warmed only by the slow heartbeat of a planet's inner heat? The possibility expands our search for life beyond the narrow band of a star's warmth, suggesting biology may thrive in places we once considered absolute voids. These dark nomads remind us that the universe is filled with shadows waiting to be illuminated by our persistent inquiry. Each faint point of infrared light, each fleeting microlensing event, is a clue in the greatest detective story of all, mapping the hidden architecture of our galaxy. If this voyage into the dark has sparked your wonder, consider subscribing for more explorations into the mysteries of space. Let us know in the comments which of these rogue wanderers, from the blazing magnetic giant to the potential watery ark, captivated your imagination the most. As you look up at the night sky, remember the emptiness is an illusion. Keep looking up and keep wondering what else moves unseen in the vast and living night.